Objective 11, more domains. We're going to build on what we learned last time. Here are three simple functions. F of x equals 2x squared plus 3x plus 5. That's a polynomial. We saw last time, last chapter, that the domain of f is all reals. Now, g of x equals sine 2x. We didn't talk about that last time, but sine of x is in the same category as polynomials. The domain of g is all reals. And you can graph a sine function, for instance. This really comes from the unit circle. The sine is y coordinates on the unit circle. And it can go round and round as many times as you want. And there's pi, there's 2 pi, there's 1, there's minus 1. Okay, and the sine function looks like this. That's one cycle of it, but it continues back and it continues forward. Not exactly like that, but you get the idea. And it continues infinite number of cycles that way, infinite number of cycles this way. This is the x coordinate, there's the y coordinate. So h of x equals e to the x, same thing. Domain of h is all reals. Of course, there are other ways to specify this. We said all reals is r with a line through it, and you also can say negative infinity to infinity, either way. E to the x basic exponential function looks like this. Okay, it takes off to infinity, and then it approaches the x-axis asymptotically. It goes infinitely to the left, and it goes infinitely to the right. This 5 up here just accelerates the growth to infinity and accelerates the exponential decay. That's all. So what use is this? Well, let's look at something a little more complicated. Let's suppose we have f of x equals square root x minus 10 plus 1 over x minus 15 plus, let me make a little bit more room here, e to the 2x plus 2x squared plus 5x and plus cosine 2x. It looks rather complicated, but this whole part, the domain is all reals. So we really can't eliminate anything from the domain on account of these three terms. This will have the same domain as g of x equals square root x minus 10 plus 1 over x minus 15. It's a different function. If you graph this on a calculator and graph this on a calculator, you'll get wildly different looking functions. But if your graphing calculator adjusts the window for the domain, or a graphing utility does, this will have values for the same x coordinates as this does, although the y coordinates will be different. So all we care about is a domain, so we can shrink it down to this and simply say x minus 10 greater than or equal to 0, domain rule number 1, and x can't be 15. Well, of course, x greater than or equal to 10, and x can't be 15. You can use set builder notation, set of all x, such that that's true. And you can be more explicit. You can draw the number line. There's 10. There's 15. That's that, but we have to poke that hole in it, etc., etc. So really, all we're doing differently here is adding these extraneous terms here that really don't affect the domain. Let's look at another example. So we have square root of x minus 5 plus square root of 10 minus x plus 2x squared plus e to the negative 3x plus sine 5x. I'm just going to say ignore these terms. So we have x minus 5 is greater than or equal to 0, and 10 minus x is greater than or equal to 0. And we can say and it's a real number, but big deal, that doesn't tell us anything. These are both domain rule number 1. Now we can solve the inequality x greater than or equal to 5, and this is actually x less than or equal to 10. A couple different ways to solve this. You can add x to both sides and get 10 greater than or equal to x. Then you could just kind of turn it around, x less than or equal to 10. Or you can say 10 minus x greater than or equal to 0, minus 10, negative x greater than or equal to negative 10. Multiply by minus 1, switch the inequality direction, and we get the same thing. Well, what does greater than or equal to 5 and less than or equal to 10 look like? That's really this. And the domain of H is really closed interval from 5 to 10. So, okay, that's about all we had to say about with domains. There are a couple of problems in your packet. They aren't any more complicated than this.